Have you ever gazed at the night sky and wondered how stars die? As we unravel the mysteries of the cosmos, we find ourselves confronting questions about the life and death of these celestial bodies. You see, stars don't simply vanish into the dark expanse of the universe. They undergo a fascinating transformation, a cycle of cosmic rebirth and death. And what's left when the lights go out? The answer lies in the tale of white dwarfs, the cosmic remnants of stars much like our own sun. Our story begins billions of years ago, with a star burning brightly in the vast expanse of space. Picture a celestial body, much like our very own sun, glowing with the energy of 1,000,000 torches and the heat of 1,000 suns. But as with all things in this universe, even stars have their life stages. After a long, fiery existence, the star eventually exhausts its nuclear fuel. The nuclear fusion that once powered it, converting hydrogen into helium, begins to dwindle. As the fusion slows down, the star's outer layers are no longer held back by the pressure of the nuclear reactions taking place at its core. This leads to the outer layers being expelled into space, creating a beautiful, ethereal spectacle known as a planetary nebula. Meanwhile, the hot, dense core of the star remains. Stripped of its outer layers, what's left is a compact, glowing object that we call a white dwarf. It's about the size of Earth, but with a mass close to that of the Sun. This tiny powerhouse continues to shine, not due to nuclear fusion, but because of the residual heat from its previous life as a full-fledged star. And thus, from the ashes of a once vibrant star, a white dwarf is born. A cosmic reminder that even in death, there is beauty, and there is life. Now, these white dwarfs, they aren't your typical stars. No, quite the contrary, these celestial bodies possess peculiarities that set them apart from the rest of the stellar family. Let's start with their size. White dwarfs, despite their intimidating name, are actually quite small. In fact, they are comparable to Earth in size, but don't let their diminutive stature fool you. These stars are denser than anything you can imagine. Picture the entire mass of our sun squeezed into an area no larger than our own planet. That's right, a teaspoon of white dwarf matter would weigh as much as an elephant. This makes them one of the densest objects in the universe, second only to neutron stars and black holes. The composition of these stars is another intriguing aspect. Predominantly made up of carbon and oxygen, white dwarfs are the crystalline remnants of stellar evolution. They are essentially the cores of dead stars, left behind after a star has exhausted its nuclear fuel and shed its outer layers. Now you might be wondering, if these stars have used up their nuclear fuel, how do they still shine? Well, that's another peculiarity of white dwarfs. They glow not because of ongoing nuclear fusion, but due to the stored thermal energy in their cores. This energy is released as light and heat, causing the white dwarf to shine. However, without a source of new energy, these stars are on a slow path to cooling and fading, destined to become black dwarfs in the distant future. White dwarfs also boast extreme temperatures. They start their life as hot as 100,000 degrees. Over billions of years, they cool down, but even a cool white dwarf is hotter than the surface of our sun. In the grand cosmic theatre, white dwarfs play a role quite unlike any other. These peculiar stars serve as a poignant reminder of the inevitable fate that awaits all but the most massive of stars. A final bow on the cosmic stage before the curtain falls. You might be wondering, why should we care about these white dwarfs? Well, let's dive right into it. White dwarfs aren't just celestial oddities. They're indispensable cosmic laboratories. They allow scientists to study matter under conditions so extreme they're impossible to replicate on Earth. Picture this. A teaspoon of white dwarf matter would weigh as much as an elephant. That's how dense these stars are. This extreme density, combined with their searing temperatures, creates a playground for physicists, enabling them to test theories about how matter behaves when it's squeezed and heated to its limits. But there's more. White dwarfs might be the unsung heroes of the cosmos, playing a key role in the dramatic spectacle of Type Ia supernovae. These stellar explosions are not only mind-bogglingly powerful but also incredibly useful. They serve as cosmic mile markers, helping astronomers measure vast intergalactic distances. And if that's not enough, white dwarfs could even be sources of gravitational waves, ripples in the fabric of space-time that give us entirely new ways to probe the mysteries of the universe. So next time you gaze up at the night sky, spare a thought for those humble white dwarfs. They may be small and unassuming, but they're doing some of the heavy lifting in our quest to understand the universe. Indeed, white dwarfs hold the key to many of the universe's most profound secrets. So, what have we unveiled about these enigmatic celestial objects? We've journeyed through the mysterious cosmos and delved into the fascinating life cycle of white dwarfs. Born from the remains of medium-sized stars, these intriguing celestial entities have a life cycle as dramatic and remarkable as the cosmos itself. They begin their journey as vibrant main-sequence stars, only to exhaust their nuclear fuel over billions of years, shedding their outer layers and leaving behind a hot, dense core, the white dwarf. Their peculiar characteristics make them stand out in the cosmic landscape. Despite being roughly the same size as our planet Earth, they pack a mass comparable to that of our Sun. This results in an incredible density, where just a teaspoon of white dwarf matter would weigh as much as an elephant on Earth. But these white dwarfs are more than just cosmic curiosities. They hold significant value in our understanding of the universe. Their predictable cooling rate allows us to calculate the age of surrounding star clusters, serving as cosmic timekeepers. Moreover, their eventual fate, either fading into a black dwarf or exploding into a type Ia supernova, provides crucial clues about the life and death of stars. In the immense cosmic drama, white dwarfs stand as silent yet eloquent testaments to the life and death of stars.